Okay, hi class. So today's class will be on classes and object, a very important topic that's for object-oriented programming. So I'm just sharing the link of you, a link to you all, which is a very good tutorial. It's in the WebEx chat box that you can check, right? So it's github.com Milan906 Python object and classes, right? You can just open your browser so that you can do together. Just type Colab in your browser, Colab, Colab, right? So, and on the first link, you have welcome to collaboratory, right? So just click that link. Actually, we have done all these things previously, so I think you may be familiar with it, right? So click on GitHub. After clicking on GitHub, it will ask you for authorization. So just authorize GitHub with your GitHub account. Fine. And now you just paste the URL that I gave you in the WebEx chat box, right? You just paste this URL here and click the search button or just press enter. That is also fine. So you will see that for that particular repository, all the IPYNB notebooks have been assigned here. So we will start with the first lesson, which is 001 underscore Python, 001 underscore Python oops, right? So you can click here and you can see it will open in Google Colab. Fine. So you can do along with me also. So full credits to Dr. Milan Parmar who has made this tutorial. I am just using his tutorial because the explanation is really very crystal clear, right? And let me start our notepad also. Let me connect this. So this is our oops class. Oops basically object oriented programming standard, right? So in Python, there is a support for procedural language as well as object oriented. Now, what do I mean by procedural? So till now, what we were doing here now is in Python was procedural. So means you have some lines in the main code, then you call a function, you call another function, let's say function to subtract, you call another function to rename, right? So what happens here in this, the assumption is that the program is divided into small modules which are known as functions, right? They are divided into small modules which are known as functions. For example, your scientific calculator has more than 500 functions. So we can assume that in the backend we have small codes which are written for each of those 500 functions, right? That is supported by the calculator. Now what happened over time, there was a paradigm shift, right? So now people started focusing more on the objects. Now what do we mean by objects? See, the terminology is a bit tricky, but the concept is simple, right? So in real world they started feeling that okay, procedural programming is not so very conducive for very large codes. Now what is the problem that is coming? So for example, you are able to write a add function, subtract function, multiply function, right? Now the issue is any user can access these functions, add, subtract, rename. Everybody is able to access these functions. In real world, there was a need wherein you wanted that okay, if I'm defining a function, there should be only few candidates that are able to access those functions, right? Now for example, and also there was a chance for code leakage. For example, when you do online transactions and all, only the bank should be able to access the function that allows you to change your password, right? Only the bank should be able to ensure that the OTP generation function should be accessible to only the banking administration team. It should not be available to general public, right? So we need to put in that kind of security mechanism also, right? To bring these kind of features, basically the procedural language like this add, subtract and rename, although these could be done in this, but it became very complicated and difficult to do, right? And that is how this concept came for object oriented programming. Like C does not have object oriented programming, but C++ has object oriented programming. Similarly, Java, Python, and all major languages now support the object oriented programming. Right? So some theory, let us just do what is Python is a multi-paradigm. Multi-paradigm means it supports object oriented and it supports normal procedural calls also that we have seen till now. Right? It supports different programming language. So one of the popular approaches to solve programming is by creating objects. So don't worry about the term object, right? This is known as object oriented programming, right? So basically what happens, what is an object, right? And I mean, how do you visualize an object? So for example, let me just give a very simple example. They have mentioned a parrot can be an object and it has the following properties, right? So for example, for the generation like you, let me just give a more valid example, right? Let me just change here a smartphone, right? It has a name, a model, and a color, and we can call SMS watch video. Right now, just see this particular example. For example, a smartphone can be viewed as an object, right? Everybody of you has a smartphone. They have different model. We have Asus gaming smartphone, then you have Realme, Xiaomi, Micromax, Nokia, Sony Ericsson. So any company you take, a smartphone will have some basic entities that can be found in everybody, right? A smartphone may have a name, let's say the company name, it may have a model. So any company, whether it's an Apple or Google or anything, they have a model, right? A smartphone has a color, black color, gray, silver, blue, right? And then a smartphone can do some kind of functions, right? So now you can see that there are two things here, attributes and behavior, right? If I take human as an object, right? So on earth there are around 770 crore humans, right? So a human can have, let's say they have some properties, right? Let's say the hair color, the color of the eyes, color of the skin, they have a name, they have a weight. So these are attributes, right? So these attributes will change with every person that you meet, right? And there are some characteristics behavior. For example, a parrot can sing, a parrot can dance. For example, using a smartphone, you can make a call to your friend, you can SMS your friend, you can watch videos on YouTube, on Netflix, etc. So just assume that everything in this world that we can see can be represented as an object, right? So it's like, for example, any smartphone, whether it is Apple, Google, Sony Ericsson, it can be treated as a object, right? For example, a specific model is treated as an object, but a general smartphone can be treated as a class. We will again come back to this example. What do I mean here, right? So the concept of OOPS in Python is creating reusable code. We will see later what do we mean by reusable code, and this concept is known as dry. Don't repeat yourself, right? Again, we will see it later. It's easy only, right? So in Python, everything is an object, right? A class is a blueprint for the object. So this particular line you will see in every book, in every tutorial, in everything, right? So now let us see what do we actually mean by a blueprint, right? Everybody knows, but let us Google blueprint, right? And let us see the images what actually appears. See, now you can see this particular blueprint for this class, right? Let me just minimize this window and have a good window here. So you can see this is the blueprint for a home, right? So what does this blueprint mean? Basically it's an artistic impression, right? Okay, this is not the real house, but any house that you make will eventually have these kind of features. It will have a door, it will have windows, a set of rooms, and all those things, right? You have studied engineering drawing in sem 2. For example, let us take this 3D model. So this basically is known as the blueprint of a house, right? Okay, after construction the house will look like this, right? So the artist will actually show this kind of impression to the people who are buying the house. So what does blueprint means? So blueprint means like a skeleton, right? It's like a skeleton. Okay, this is how the house will look, because for example in a locality this particular builder is selling 100 such independent houses, right? So all the houses will look like this, but every house owner may paint the house according to his or her needs, right? They may try to change the design of the main door. They may try to keep some more decorative items outside. So this is personal preference. But the blueprint means the builder is saying that, okay, my entire 100 houses will be exactly like this. Later, you can modify the way you want, right? So for example, in my Python programming, I have 143 students, right? So these students are 143 objects for me. But in the terms of class blueprint, the syllabus becomes the blueprint. All the students have to attain and follow the same syllabus, right? So a very brief overview of what is a blueprint, right? So people write a class is a blueprint of an object. So when we see the examples, we will actually get it more clear. And class represents the properties, right? Properties again, or attributes, right? These two words are used interchangeably. So always when you are dealing with class, right? So you can always have a very good example which you can relate. So let's say class a smartphone, right? Let us forget about the syntax and everything. A smartphone will have a name, it will have a color, right? It will have a, so let's say we keep this as brand name, color, and let's say, oh, sorry, this is a model name, right? These are the properties or attributes, both are same. So, and now let me change the pen color, and there are some functions here. Call, SMS, let's say watch videos. So these are called methods or functions. Now you may ask, what is the difference between a method or a property? See, now you can see when you call your friend, you cannot have a static template of what you will talk actually to your friend. You may talk for 1 minute, you may talk for 30 minutes, you may talk for 1 hour, right? But let's say the brand name. So brand name is fixed. For example, Apple, right? This does not change. As long as you have that particular cell phone in your hand, the brand name always remains static. Similarly, color may be blue or black, something like this. So this is a property of that, right? So let's say we may say ki, okay, Indians, the eye color of most Indians is black. So this is a property. Most of the eye color of Indians is black, right? A blonde may have a brown hair, right? So that is the property. But let's say you have a functionality called call. For example, a human sings, right? So sing, basically it's a function, right? So you may sing a Hindi song, you may sing an English song, you may sing a Marathi song, something like this. So this is like a function. We do not know what it will actually do in that, but we know that it is some kind of a function that will be performed by it, right? So you can do an SMS through your smartphone, you can watch videos on YouTube on your smartphone. So these are functions, right? So usually what happens, functions are actually verbs, if you see, right? Calling someone is a verb. Calling is a verb, right? You're calling, you're doing some task. Watching videos. So watching is an activity. It's a verb, right? So here they say that, okay, we can think of a class as a sketch of a parrot with labels, right? So I just showed you the example of the blueprint, right? So blueprint of a house is also the same thing. Now, what is the syntax that we use in Python, right? The syntax that we are using here is class, the name of the class that you specify, just like you specify integer and then you specify the name of the variable. Class, let us take a break for 2 minutes and then we will start this. Hi class, welcome after the break. So now we will see the syntax of a class in Python. So just like for example, this is similar to structures that you remember from C, right? C has structures, so this is similar. Class name, right? This is documentation string. This is nothing but basically triple quotes, just saying what this class does, right? Since this is comment, so you can also skip it. And this is class suit. So we will see what is a class suit. Basically, in structures, if you remember, If you remember, right, we had something like this, right? Struck student, right? And then we had a brace here, like let's say int age, character name 20, and then we had functions, let's say void add some body, and finally we close the structure. So now if you see here in this case, if I make a similar thing, it is exactly same. Instead of struct, we have class. So this can be another name. So let's say this I am saying as person, right? In Python, we don't define int and all. We will see what actually is to be done, right? We have functions also in Python. So similar to that. So for example, in this case, the simplest example of a class in Python can be, I am defining the name of a class. I am defining the name is parrot, and then I am just writing one thing here, which is pass. So we have already seen what does pass mean. Pass basically means nothing. You just pass it on. So for example, in this, when I execute this code, okay, this is just a text actually. Similarly, in this case, what happens? Okay, let us see this example. Class person. I am doing pass here, right? And then what I am doing, I am printing person. See, person is the name of the class. There is a convention generally that you keep the class names as capitals, starting capitals, all other strings are small, right? Capitalized case. Let me just run this code. Right, so what is the output here? Class. You can see this is the class here, and main and person is the name of the class, and basically we will see what is underscore underscore main and underscore underscore, right? If you want to see that importance, for example, when I'm doing a is equal to 5 and I do print type of a, right? We of course know a is a type of integer. So just see the output. So you can see it says integer, but you can see the previous word is class, right? Similarly, if I make a as a string, it will say class str, right? So basically, a is an object of class string. Everything in Python is an object, right? Everything in Python is an object. So a here in this case is a string object. Now a becomes a integer object. Now a in this case becomes a floating object. Again, it will have a class float, right? Python, since it's open source, you can actually see the browse and see what does the class float look like, right? So now what I'm doing here, I'm just creating a class person here, and I'm doing nothing basically. I'm just doing a pass here, right? And I'm just printing person, which is name of the class. So what does it print? It basically says that person is a class object, just like float is a class. It says person is a class. That's it. So let us see which we do type person, right? So it says person is of type class, right? So now you can see this person is not inbuilt, right? This we have created. Right, so we have created this person class. This is our custom class, right? Like class float you cannot create. If I write here class float, it should pop up an error. Okay, it did not pop up an error. It just says class type, right? But we cannot, of course we can actually override the inbuilt classes also, but let us now forget those things, right? Now what is an object? As I said, when you compare smartphone as a class, right? So let us do one thing. Make this smartphone, right? Current generation can relate very well to the smartphone. So smartphone is a class. Now every smartphone will have some basic features: color, model, company name, right? And some functions: call, SMS, video call, etc, etc. Now what is an object? So all the cell phones in the world that are actually made are all objects, right? So for example, if I say class human, so let me keep this human. So all the 770 crore people in the world, or the 7 billion people in the world, are objects of this main class, which is human, right? Because human will have a weight, a human has eyes, nose, head, ear, hands, and legs, right? So that is the class. The blueprint is, okay, a living person having hands, eye, legs, ear, head, and all those things, right? So now what happens? How do you define an object, right? So you have defined a class here, a class human, a class smartphone, a class person. So how do you define an object now? So for defining an object, the syntax is like this. Reference variable is equal to class name. So for example, here we have created the parrot class, right? There was a class called parrot, right? So you can have any variable name. The same rules for variable names also apply here. Object is equal to, and this is the name of the class, right? So what happens here? Let us see this example. I am having a class called person. So you can see this is the person class. If you want to make an object of it, right? So now you can just take the house example, right? So house example, you saw the blueprint. Just a second, I don't know how. Okay, you saw this house example. This was the blueprint. Now let's say when we are creating an object, you assume in this case, I'm just giving an analogy, that one person has come to buy this house, right? So the builder will say, okay, I will construct a house for you, but the person will say, okay, I need the outside walls to be white in color, right? The terraces walls should be probably in red color, and the main entrance door should be completely white in color, right? So this will be the house that will be first constructed, and these kind of decorative things or the individual house properties basically are the object, right? So whenever you're defining an object, for example, this is the name of the class, right? So let us come to our notebook. So let's say you have a class person, right? And here we are having just pass, right? And now let me change my pen color, and let's say I'm making a person one, right? Person one is equal to person and in the bracket, right? So let me again change the pen color. So you can see this is exactly same as this has to be the same. So when you are creating an object, right, this is an object, this is class name, and these are parentheses, right? So basically this means that now person one is an object of class person. If I relate this to a smartphone, if I have a class smartphone, this may represent an iPhone, this may represent a Realme Narzo phone, right? This may represent a Poco F1 phone or a Nokia 3310 phone if it was a smartphone class. Fine. So now let us see what happens when you make a object, right? So for example, I'm making P is equal to person. That means from the person class, I am making an object whose name is P, right? And I'm just printing the value of P, right? So see, it says main that we just saw previously. Person is the name of the class, and you can see it's an object, right? Let me also write here type of P, right? So you can see class, main, and person, right? Basically, person is a type of object, but basically what happens here, see, person is a class, right? So it says the type, it basically says ki, okay, P is basically an object of class person, right? Now let us see what happens, how to create a class and object. So this is a complete example in this case, right? So I'm making a new class which is called as student, right? Class student. What happens here? You can see here I am defining a function here, define learn. Okay, forget the keyword self now, we will see it a little. forget the keyword self now, it is mandatory to be put here. So we have a sample method here, right? And basically we are printing welcome to Dr. Milan Parmar's class on Python programming. Basically this is the author of this particular GitHub IP1YNB notebook. So what happens, see, I have a class here student. So you can see when I selected student, this student also got highlighted, right? So in this case, stud becomes my object. I can create as many objects as I want, right? So let me create another student here, stud1, okay, stud2. Then let us create stud3, stud3, right? So when I execute this code, you can see I will have 3 times output. Why? Because the moment I create an object, okay, memory is allotted, right? The moment you create an object here, the memory, memory, memory allotted, right? Now see what I'm doing, I'm calling the learn function, right? Now you will say, sir, since the definition of learn, basically it is a defined learn function, why can't we directly just write learn like a normal code, right? So this is the difference between classes and objects. See, we have a class here, student, right? Do you remember I telling you that, we need to have some kind of mechanism that only the banking administrator can access their OTP functions for security reason. Not everybody else can do that, right? So what happens here when you have a class student, right? So let me just show you a visual example here. So when you make a class student, right? This is a class student, right? And you have a function here, definition learn, right? And you have some hello world and all those things. Now what happened in the main, let's say I'm creating the first student of my class. Let's say I am creating a student Abhishek is equal to, how will I do? I will write student and put a parenthesis. So this is, what is the object? Object is Abhishek. Fine. Now since Abhishek is, let me change the pen color. Now since Abhishek is an object, this is an object of which class? Student class, right? So Abhishek can actually access the learn function, Why? Because Abhishek is an object of class student, so Abhishek can access the learn function. Now let us take another example. It may be a bit confusing as of now. Let me take another class. This is class smartphone. Let's say we have a functionality here, call functionality, and it has some lines here, right? So now let me check. Apple iPhone is an object here for the smartphone. So what happens here? This is an object. So again, pen change. So Apple iPhone is an object of which class? It's a smartphone class, right? So now we have two classes here, right? So let me make this as red color. Class 1 and class 2, right? This is class 2. So what happens now in this case? When I am calling Abhishek.learn, right? So what happens? What does the interpreter check? It first checks whether learn function exists or not, right? Not that. First it checks, okay, Abhishek belongs to which class? So it says, okay, Abhishek belongs to the student class, right? Now, whether the student class has the learn function. So you can see the student class has the learn function. So Abhishek.learn can access this learn function without any issues. So Abhishek can access the learn function without any issues. Now let's say what happens. Let me cite a wrong example now so that you understand. So let's say this is a call function. Now Abhishek dot call. Now what happens in this particular case? So in this case, Abhishek is an object of student class, right? So Abhishek is an object of student class. Does student class have this call function? No. And there is a double check here. So now it checks which class has the call function. So you can see the smartphone class has the call function, right? The smartphone class has the call function. Is Abhishek an object of smartphone? No, right? So Abhishek cannot call this. The interpreter will throw an error, right? So are you realizing this, how easily we are able to implement this kind of security mechanism, right? So we will see this is basically known as encapsulation, but I'm just giving you an idea. So once you create an object for, let's say, student, you can access only functions meant for that class. Once you create an iPhone object, you can only access functions which are basically defined for the smartphone class. So for example, if I write here apple underscore iPhone dot learn, again it will give an error. Why? Because Apple iPhone is a part of the smartphone class, and smartphone class does not have a learn function. Fine. Okay, so let us come back here. Fine. So this is how basically it works. So for example, let me just show you this example. Let me try to make this a smartphone. So let me just this calling 911. Oh, sorry for the spelling. Smartphone is here. And let me create another object. Okay, so let me remove this object, two students, and let's say iPhone is equal to smartphone, right? And iPhone has a iPhone dot call. So you can see calling 911. Why? Because iPhone was a smartphone object. So smartphone object can call the smartphone class functions. Similarly, student can call the learn object. Now let us try a wrong thing. I say iPhone.learn. So let us see what error we get. See, it has shown in the red. Now it will say smartphone object has no attribute learn, right? It is saying attribute, basically it's a method, right? So what I'm doing iPhone.learn. iPhone is an object of smartphone. Smartphone has only the call method basically defined for itself. Similarly, the other will also not work. So for example, if you write stud2.call, again it will give the same error. See, it says student object has no attribute call. Why? Because student object is of class student, and the definition here is call. I mean, the definition of call is not present here, right? So this is how things work in classes and objects. Just remember one thing, whatever object I am creating, identify which class it belongs to. For example, stud belongs to the smartphone class. Sorry, stud belongs to the student class, iPhone belongs to the smartphone class. So iPhone can only access functions which are written inside smartphone. Student can only access those functions which are written inside student call. in the student class, right? So this is how you differentiate. Let me just run the code again so that we have a code with no errors. So you can see iphone.call basically is calling 911, right? One more interesting thing that you observe here is that, for example, if I make the name of the function same, definition learn and definition learn, right? Now I will tell you how the self concept works. Now what do you mean by self, right? Self basically is myself, right? We say myself Mayank Agarwal, or myself Sachin Tendulkar, something like this. Self means you are referring to your own self. Now you just see this, right? You can see the output is again the same. Welcome to Dr. Milan Parmar, and I'm doing calling 911, right? Now why did this happen? Now since both the function name are learn, how did student know that okay, we need to call this definition of learn, right? Even I keep identical definition, right? Let me keep identical definition so that no confusion, and let me run the code. You can see same 3 lines. Okay, so see, if the lines are same, you will not be able to understand okay which function is being called. But as we know, we can have two functions with the same definition when using a class. Now we will see the concept of self. And also remove this method, right? So let us have only two objects. One is student object and one is smartphone object. See, when I do student dot learn, right? When I do student dot learn, so basically the interpreter checks that okay, student is an object of class student. So when I am calling the learn function using the student object sees that okay, I belong to the class student, so I should first come here, and once I come here, I should execute the learn that is belonging to the class student, right? That is belonging to the class student, right? So you can just see this like a passport, right? So let's say you have an Indian passport, and let's say you have a friend who is in UK, he has a UK passport, right? So both of them basically go to the immigration office or the passport office of your respective country, right? So when you verify, so each countries, for example, an Indian passport will only be verified in an Indian country, right? An Indian embassy will basically validate that passport. Similarly, a British embassy will basically validate the passport. Both are embassies only, right? Both are embassies, just like both are learn functions only. But if you are carrying an Indian passport, you need to go to an Indian embassy only. So what happens here? When I am calling stud.learn, the compiler checks, okay, stud is an object of student class. And so I come to the student class, and now I search whether I have a learn function implemented. If yes, I will execute that function. If not, right? If not, then I will basically pop up an error. So for example, if I do student dot learn and write, this function does not exist. So do you see now it will pop an error? That stored object has no attribute learn write, right? Now what happens when I'm making an iPhone object for smartphone? The smartphone basically, when I'm calling iphone.learn, it sees okay, iPhone belongs to which class? It belongs to smartphone class, right? Now I come to the smartphone class. Now it checks whether learn is implemented in smartphone. So it says, yeah, learn is implemented in smartphone. So it prints out calling 911. Now, where does self come here? Self means, for example, when I'm calling stud.learn, in this case, stud is the object that is calling this function. So basically, it basically represents the object which is calling the function. Now I'm telling you an example. So let's say there are two students in the class. Let's say, okay, let us take a very live example. Let me go to the chat window, participants, right? So we have Ankit here and we have Shreya here, right? So if I ask Shreya, okay, what is your name? She may reply that, okay, myself, Shreya. right? When I ask Ankit, what is your name? Then Ankit will say, myself Ankit, right? So now when Ankit is saying myself Ankit, right, and Shreya is saying myself Shreya. So you can see they are both using the word myself, but they are replacing the first name by their own name. Both of them use myself Shreya, myself Ankit. You can see myself is same for both, but both of them are basically having their own names replaced after myself, right? They don't both say myself Ankit or myself Shreya. So the same concept goes for self. In self, I am saying that whatever object is calling this particular function, that is the owner of it. So when I'm saying stud.learn, it means I am calling this function with stud. So indirectly, when I'm calling the stud, self is basically replaced by stud. If I'm basically now declaring another object, let us say stud2. So in this case, when I call this function, self basically will become stud2. So self means whoever is calling or accessing that attribute. So when I do iPhone here, self will be iPhone in this particular case, right? So I hope you get this concept. So when you say myself Ankit, myself Shreya, or myself Abhijit, right? So you can see myself is common. Only the objects are getting changed. Only the human names are getting replaced, right? So class, for constructor we will see tomorrow. Tomorrow anyways is the last class for this particular semester. This week you have actually many assignments and quizzes also, right? So tomorrow also will be a class here, and then I'm let me see if I can cover at least till inheritance. You will at least have a very basic idea about classes and objects, right guys? So thank you for attending today's lecture. Have a good day. Any doubts are welcome, or else I just upload the lecture on YouTube also.